most often it's really written like this. I don't know how it's in your book. I haven't taken a look at that thing. Who's got the book here? Anybody have the book? Is it written as UV minus VDU is equal to UdV, or is it written like UV minus UdV is equal to VDU? Which one? One of these two. Just be consistent with the book. Not a big deal because these are just letters. This one? Yeah. Okay, let's go. This is called the integration by parts formula. On the exam, you should write it down. Integration by parts formula. UdV is equal to UV minus VDU. What is the meaning of that? The meaning of that, you may want to put your pen down for a minute, is that you are trying to integrate something. Or what I would do with that. And then you have no idea how to integrate. But you do know that it's the same as this. Then you have another integration problem. But hopefully that doesn't say nice. So you say you have an integral, and if you do integration by parts, you can write it like this. You may be jumping out of the frying pan into the fire, or you may actually be making your problem easier. And if you are jumping out of the frying pan into the fire, you have a more difficult integral. You've done one or two things wrong. One of them is that the integration by parts is not going to help you. Or the other is you didn't set it up correctly. What it means is that you are trying to integrate something which you recognize as the integral of some function multiplied by the derivative of another function. The integral of a function multiplied by the derivative of the function. The integral of that thing. You can rewrite it as the integral of the thing that is derivated. Then the integral of the thing that you just integrated. And then differentiate the thing that was not differentiated. And that is the trick with the integration by parts, is to recognize, well, how do you do that? What is what? I'll do a very simple example. Let's say I want to integrate this. Now, this problem you cannot do but by integration by parts. So you are going to have to translate this to this. So you're going to say, this is something I don't know how to do. Something I don't know how to integrate. So I'm going to have to write it like this and then change it to that. So let me take yourself down. Well, what is what? You will see that the u is being differentiated. and that the dv is being integrated. So you should say to yourself, what is it that you want to differentiate and what is it that you want to integrate to make your problem a little easier? Now, if you are going to integrate x, you are going to get what? X squared over 2, probably making this a lot more complicated. If you differentiate x, you will get 1, probably making this one a little easier. Again, if you want to say integrate the x, you're going to make this harder. Because you're going to get x squared over 2. The derivative of dx dx. That is the case of jumping out of the frying pan into the fire. Whereas if you say, let's differentiate the x, well, differentiate the x, so this is going to make this integral easier. And then whatever that is, we do whatever it is, there's no integration here. Let's see. So when I do these problems, well, I don't do these problems. When I did them many years ago, I really wrote the integration by parts formula down. I encourage you to do the same, although a lot of people on the test, they don't do it. I don't know why. So the integration by parts formula is what? U dv is equal to uv minus v du. And you write down the problem that you have in your hand here. Now, that is not to say that this is this and this is this. You may have to switch it out. That will be for you to decide. What is going to make your problem? But I think you all agree that it is the x I want to differentiate and the e to the x I want to integrate. So I take another piece of paper, but then I also write it on my pen. Say, hey, here's my work. I need to identify this with something here, and I need to identify this with something here. Now, what it is, who knows? You may have to switch it out. But in this case, it's clear. Done. So now you have to say, well, if this is u and this is dv, then what is du and what is v? I mean, this guy is taken care of. What are you going to put here? Correct. Now the question is, what is v? So I have to integrate this thing. I do that here. U is equal to what? X. And dv is equal to what?
Edx dx.
Correct. So now I'm going to need what? Du. And I'm going to need what? V. So that I will put that there and that there and that there. Well, what is du by dx? 1. So that du is dx. What's coming here? dx. Now we have to figure this out. We'll just integrate this, huh? What is this?
V.
What is this?
Edx.
Plus c. No, don't worry about the c when you do integration by parts. You do it at the end. I'm ready to rock and roll now. What's u?
X.
What's v?
Edx.
What's v? What's du?
Edx.
And that is a nice problem. That is to say, we have differentiated out the x that was causing a problem with the integration to begin with.
Can we go back over how you got the stuff on the left-hand side of your?
Calculus 1. U is equal to x, du by dx is equal to 1. So du is equal to dx.
Okay.
The dv is equal to e to the x dx, integrate that, integral of dv is v, and the integral of e to the x dx is e to the x. Clear? And now we will say, well, what is this? Constant. So there is the antiderivative of x e to the x dx. And who believes me? Who doesn't believe me? I will check it by differentiating this and see that I get this. You can go home and do it. I assure you it's correct. All right? That if I differentiate this, I will get this. You want to try it? Now, I can tell you nothing about what you want to integrate and what you want to differentiate. That is for you too.